Welcome to your video on Newton's laws. So the first thing we're going to look at today is mass. Okay, so when we talk about the mass of an object, we're actually talking about the amount of matter that is in that object. Okay, so if we take our box here we go, it is 10 kilograms, has a mass of 10 kilograms. That means it's got 10 kilograms of stuff in it. The atoms that make up that box have a mass of 10 kilograms. That is going to remain the same wherever it goes in the universe. Okay. What will change though is the weight. Okay. The weight is the force of gravity acting on a mass. So gravity is effectively something of mass pulling other things of mass towards it. Okay. So on Earth or on any other planet, we're going to have a weight acting downwards. It's a force, so it has a direction. Okay. So it is a vector quantity. Mass is a scalar quantity. It has no direction. Okay, to calculate the weight, so let's calculate the weight on Earth, because on Earth we know that gravitational field strength is 10 newtons per kilogram. Okay, to calculate weight, we just use weight equals mass times gravity. Okay, if we look at our example up here, we've got a mass of 10 kilograms times a gravitational field strength of 10 newtons per kilogram. Okay, and that is just going to give us 100 newtons. So that box of 10 kilograms has a weight of 100 newtons. It's very important that we use these words correctly. Okay, so the amount of matter that we are made up of is our mass. So when we measure our mass using the scales in the bathroom, we're measuring it in kilograms. Okay, and the force that is producing, acting downwards, is our weight. Okay, and we multiply our mass by the gravitational field strength. Okay, now we're going to look at inertia. Okay, so inertia is a resistance to a change of motion. Okay, so how difficult is it to make something move faster or make it slow down? Okay, so if we think about a bowling ball, there's our bowling ball. Okay, it looks like a bit of a person there. Okay, and a little ping pong ball. Okay, this has got a big mass. This has a very small mass. It's very easy to stop the ping pong ball with a very low mass. It's very difficult to stop the bowling ball with a large mass. Okay, so if we have a large mass, it's very difficult to stop, yeah, because it's inertia. Okay, and if we've got a small mass, the ping pong ball is very easy to stop. Okay, so if we think about things like oil tankers or shipping containers, they have huge masses. They are very difficult to get moving, very difficult to slow down, very difficult to change their direction. Okay, and that brings us on to Newton's first law. An object travelling at a constant velocity will continue to do so unless acted upon by a resultant force. So, a resultant force is the overall force acting on an object. Okay? If an object has balanced forces, it will stay still. That means hovering or floating. It won't move, but it will move at a constant velocity. So that's the same speed, same direction, and travelling in a straight line. Okay? So what these forces can do is they can speed us up, slow us down, or change our direction. Okay, so with that in mind, now knowing Newton's law, and this is something that you must know. Okay, so you should write that down. There should be a question to go with this video, the OMG questions, so you should be answering those. Okay, Newton's law, first law, very important. You might want to pause and write that. Okay, resultant forces. Okay, so the resultant forces are the overall force acting on an object. So in this case of this blue car, we have the engine force and we have the drag forces, so the friction from the wheels and the air resistance on the vehicle. Okay, these forces are balanced, so that vehicle has no resultant force acting on it. It will continue to travel at the same speed in the same direction. Again, this vehicle, the weight, and we can tell by the arrow, the weight and the normal reaction force are the same size. They're acting in opposite directions, so we have no resultant force. Okay, so it continues to travel at the same speed in the same direction. This vehicle is not moving, okay? Therefore, its velocity is 0. Same speed, same direction, right? So, to calculate the resultant force, all we need to do is add the forces together, okay? So, for this case at the top, we've got a thrust force, and we add minus 5,000 newtons because they're in opposite directions. Much like when we have acceleration, we can have positive acceleration, getting faster, or we can have negative acceleration, deceleration, getting slower. Okay, so let's look at this example at the bottom. Okay, so let's say the weight of the car is 2,000 newtons. Okay, the normal reaction force is 2,000 newtons, but we need to say that down is positive in this case. Okay, so we're going to do the overall force, the resultant force, equals the weight minus the reaction force, okay? Or added to the reaction force, sorry. Okay, so the weight is 2,000 newtons, okay? And then we're going to add, but because down is positive, we're going to add minus 2,000 newtons, okay? Okay? And then that is obviously 2,000, take away 2,000 equals 0 newtons, okay? Very important that we remember our units. They are worth a mark in your exam, and they make sure people know that you're talking about forces, okay? Right, Newton's second law. A resultant force acting on an object will cause an object to accelerate, but, taking that further, the size of the force is directly proportional to the size of the acceleration, okay? So, force is directly proportional to acceleration. Okay, so the resultant force, if you double the resultant force, you double the acceleration. We have an example here where we have a mass of 1,500 kilograms and a force of 4,500 newtons. So we need to find the acceleration. So the first thing we do, we write down what we know. So the force is 4,500 newtons. The mass is 1,500 kilograms. Okay, we don't know the acceleration, so let's write our equation. F equals ma. Substitute in our values. Okay, we don't know a, so we can leave it as a. All right, now we're going to divide each side by 1,500. Okay, so we get 4,500 divided by 1,500. Okay, we put that into a calculator and we find out that the acceleration is 3 meters per second squared. And remember, we need to use the correct units. So, finally, we have Newton's third law. So, for every action force, there is an equal and opposite reaction force. Okay, so think about standing up from sitting. You push down with a force greater than your weight, and the ground will push back with the same force. Okay, this person here, in this example, is object A, pushing against the wall is pushing back against them. Okay, if that didn't happen, and we didn't have Newton's third laws, all sorts of things would be going wrong. Okay, we'd be falling through walls. Okay, there'd still be a reaction force, but the force wouldn't support you. Okay, and we'd be in trouble. So, oh my God, video complete. OMG questions now need to be completed in your notebook or on paper. Okay, and that is forming part of your revision. Thank you very much for watching. Please ask your teacher if you have any questions. Thank you very much. Goodbye.